gonna run everybody through how to hook up an AC cord. It's one thing that you would do to an amp that isn't exactly how it's wired up when it comes in. A lot of things with repair, you're just replacing things with the same value and the same way that it was built from the factory. You're just putting a new part in. But an AC cable, you're going to actually change how it's wired in a lot of cases, specifically when you're going from a 2-prong to a 3-prong. So I'm going to bring up a slide, do a little screen share. Okay, so I'm an excellent artist, and I drew this with colored pencils. This is just the generic way how to wire up any amp. So you got your AC cable, goes into the side of the chassis. Then you got 3 wires. You got a hot wire, white wire, and your green wire. Green wire is connected to that center lug that plugs into your outlet. If you're looking at an outlet, on the right side of the outlet is your hot, and on the left side of the outlet is your neutral. When it goes into the amp, the black wire from the AC cord gets directly connected to the fuse. Code is for if you have one of those black fuse holders that sticks out of the side of the chassis, the black wire from the AC cable should be hooked to the very end of the fuse holder. The reason for that is if you are changing a fuse and you happen to have left the cable connected to the outlet, that it is the first thing that is disconnected from the circuit. So a fuse has 2 metal ends on it with a glass in between. And if it's touching the very, very end of that fuse holder, it's connected to the wall. So when you unscrew it, it disconnects it, and it's the safest way. So black hot wire to the end of the fuse holder, then you connect a wire straight to the switch. On the other side of the switch is your black, it's usually black wire that goes into your transformer. That is the primary side of your transformer. Then there's another black wire that comes out of the transformer, and that's connected directly to your white neutral line. In this picture, I have a terminal strip. This is supposed to be a picture of a terminal strip where it's connected. It's not connected to anything else. It's just on that fiber board, and it's not connected to anything else. And then that middle lug is connected to the green ground wire, and it is also connected directly to the chassis. And that's it. That's how you wire it up. Now, what you'll find with a 2-prong, an amp that just has 2 prongs, there will be no ground wire. There'll be a black hot wire and a neutral. And a lot of times the way they wired them up was that the white neutral line was connected to a switch and the black hot wire was connected to the fuse. So you can see that modern code has it changed from you want the hot wire to be switched, because if the hot wire is not going into the transformer. So there's no electricity getting into the transformer. The only electricity that's in the amp when the amp is turned off is that fuse and half of the switch. If you hooked it up the other way, like the way a 2-prong is normally hooked up, that black wire is hooked up to the fuse, and then it goes straight into the transformer. So there's always current flowing into the transformer, but with the white neutral line from the house, because it's not switched, it doesn't create a full circuit. So that's why we change it for the black wire to be on the fuse and on a switch, and there's nothing going on inside of the amp.
Is that for safety, or is that for longevity of life of your transformer, or both?
For safety.
Yeah. Okay.
Yep. Or I mean, yeah. No, there's not the current isn't really flowing through the transformer as if your power is switched, right? But it could be. All right, so this is the generic one, and then let me just switch over to this one by Rob Hall. So this is the same thing that I drew, except it's exactly what you'll see inside of most Fender amps, or all Fender amps. So the on the left side of the screen, you got the AC cable coming into the chassis. You got the green wire hooked up directly to a lug that is connected directly to the chassis. Then you have the white wire that's connected to the auxiliary AC outlet that's in the back of a lot of amps. And then you can see that is connected to there's another wire going that goes to this ground switch, which we were just kind of using as a terminal. The ground switch is actually disconnected. So after you move the chassis ground, then the ground switch is disconnected. Okay, so you're just using this terminal here that I'm following along with my clicker. That's just the terminal that goes straight into the transformer. So it's just, they just do it a different way. You could put a terminal strip right here on this chassis ground, and you could connect the white to the black. But with Fenders, especially ones that might be collectible or something like that, you try to not to disturb as many things as you can. So remove this capacitor. This is chassis ground capacitor. This is what a lot of people refer to as the death cap. I think that's a little dramatic to calls it a death cap. I don't think any of these capacitors have ever killed anybody. Typically when a capacitor fails, it fails open. The reason the death cap gets its name is because there's the potential for the capacitor to fail closed, and that would make a direct connection to the chassis. If it's a two-prong cord, it would not blow a fuse, and it wouldn't blow the circuit breaker because there's no ground reference. So you would just basically have a big chassis conductor. The chassis would have 120 volts on it, and it would have full current. You'd have 15 amps coming through that bad boy. So touching that would not feel good. But typically that switch, if it's a two-prong cord and you have it reversed, you only have as much current as that capacitor will let through. Because if you remember from my other talk, capacitors let AC voltage through. It does not let DC through. So the voltage that we have on the wall is AC. So it will go through that capacitor, but it will only go as much. The capacitors have resistance. So the capacitors that are used for the death cap can allow, like, I forget exactly how much current. It's like 2 amps or something like that, which just doesn't feel good. It's not going to kill you. And it should, I think Rob Hall says something in his website. It should be called the "Ow, that really hurt" cap. So that's the little spiel on death caps. Just clip it out. You can even clip it out and leave it in the amp if you wanted to keep something really, really original. But just remove it. And then the black wire is connected to the AC receptacle. And then there's a wire that's connected to the other side of the ground switch. Then from there, it's just acting as a terminal. It goes to the back of the fuse, and then out from the fuse, it goes to the AC switch. And boom, there you go. Keep these for reference. Yeah, I mean, I can wire them in my sleep, but
Luke, so when you're saying you're taking that green wire to the ground chassis, are you adding a screw to the chassis and putting that on there, or is there already some kind of receptacle for it on the chassis?
So sometimes there is, and sometimes there's not. If you're replacing a two-prong cord, then there will not be. You'll have to add it or add it to something else. Per code, your green ground wire should be connected to a place in the chassis all by itself. There's also ground connections, even though they all seem like they're just connected all wherever in the chassis. They do have specific purposes, and it is important to maintain the ground connections in the amplifier as they were designed, unless you really know what you're doing and you think you can change it. So when you're adding a wire, you should make your own connection somewhere in the chassis separate from anything else. Don't add it to like the center taps on the transformers. Don't add it to like where the electrolytic capacitors are grounded to. You should make something separate. So what you can do is, sorry, you want to say something that?
Oh, I was just going to ask you what is your preferred fastener kind of setup for that?
So for most Fender amps, I like to ground it directly to, sorry, that's silly. I like to ground it directly to the chassis, which I just I make a little pad and sand the chassis, and then I get my big hot soldering iron, my big 80-watt soldering iron, and solder it direct to the chassis like a lot of the other grounds. That's what looks most original. I don't like to drill a hole in the chassis, though I believe the code is the European Union electrical code is to drill a hole through the chassis and connect a ground wire. So if I were building an amp, that's how I would do it. I would drill a hole in the chassis, have a terminal lug, and have the ground to that, and then on the other terminal lug, on that same lug that we're adding, I would just connect the white. Does that make sense?
It does to me.
It would. I would run it exactly how I drew it out in that picture if I was making my own amp. Some people, you can connect them to the transformer screw, but it's not good practice because transformers actually vibrate a little bit. If you ever turn on a lot of amps, you can like turn them on, and you actually feel them like vibrating if you put your hand on it. And theoretically, the screw can come loose. The screw comes loose, then the chassis, then you don't have a good ground reference. It's not the best of situations, but I mean, if you put a little thread lock on there, I don't know, they won't come undone. But that's one thing. That is one thing to check when you're opening up old amps, is check all the transformer screws. A lot of times they are loose, but it's not like the bolts floating around in the chassis or anything. I think that's it. Does that make sense?
Yeah. Does anybody have any questions besides me?
All right. So at this point, I would like to show you actually how to wire it up, but unfortunately, I don't have an amp in here that needs a 3-prong cord. I'm kind of trying not to take any more repairs in until I can clear my shop out on this completely, because like the rest of you, it sounds like just been completely swamped with things. Excel sheet. So Fender Blues Juniors, Hot Rod DeVilles, Hot Rod Deluxes, they are like they probably made more of those amps than they've made of any other amp combined. There's always one in the shop. If you were doing guitar repair and you just wanted to dabble in amp repair a little bit, you could just take in Blues Juniors, Hot Rod Deluxe, and Hot Rod DeVilles, and you could probably pay your rent just by fixing those amps. There's just a lot of them, and they all need work. They're a staple. There are a lot of backline amps. A lot of places use them at backline amps, and people take them on the road. And so let me show you this Blues Junior. I'm going to switch to the video where you can actually see it, and I can show you. I'll show you what the.
Look, what's the so which amp is this one in particular?
This is a Fender Blues Junior.
So, okay, what's the retail price on something like this? Like,
I think they're like $400, give or take. I don't know what they go for exactly brand new. This is a tweed one. They have black and white and tweed. Most of them are black. Um,
I remember these were coming out when I was just starting in guitars in the 90s. Is there like, is this the same amp from the 90s, or is this like?
Yep. This one, yeah, this one, they're the same. There were some schematic changes, but there is a couple of changed parts, but by and large, they're exactly the same amp.
Okay.
So this amp came in because it stopped working. He said it just stopped working. I think maybe it blew a fuse. So let me show you. I'm gonna pick up the camera and kind of go around it a little bit, show you what the most common things are. So the most common thing is this jack breaks. Some of the years, some years are more susceptible to complete failure than others. I actually think the newer ones, like 2010 and later, they don't fail as often. But you have to pull the board out to replace any of this stuff. So you might as well replace this while you're in there. And I replace it with a Switchcraft jack. That's like you see it in a guitar, except you use a shorting lug. So it has, this is a shorting lug. You see it has that extra little guy on the tip there. And that's so the signal gets grounded when there's nothing plugged into it. So you would run some new wires and connect it directly to that new jack and put that jack in. You can also change the grounding point for it. So you have a ground connection over here that runs directly to the chassis. It's better if you take this, snip that lead and take it directly to the jack. And then these are your electrolytic capacitors, these big guys right here. They have a polarity, a positive and a minus. They're big voltage. That's what keeps your amp from humming. That's what filters, that's what we call the filter supply or filter in the DC. They should all be replaced. And you don't need to know anything in theory about how amps work to do this kind of work. You just literally open these things up, replace this one, and then replace that jack.
Are you deciding to change those just based on the life of the amp and knowing that they're or the date of the amp and like how old they are, or is there a testing procedure that you go through on that?
Nope, they all suck. They were poor quality from the factory.
Okay.
A lot of time brand new ones just like leak. So if one comes in for repair and you got to pull this board, you should just replace it, because the most labor cost. So I'll tell you what I charge. So $80 for a service, and then $80 to pull the board. So if I have to say the amp's not working and it's like one bad resistor in here, like a plate resistor goes bad, and I find it like, yep, plate resistor goes bad, I have to pull the board to replace that plate resistor.
Okay.
I think that's the right way to do it. You could do it a cheaper way. You could snip the lead like here and here, and then basically like tie a resistor in. But it's not a good solid repair. You know, you should remove the resistor from the circuit.
Remove it, yeah.
And then add it to the circuit.
Can I back you up one more thing too? Where are you running the leads to from the board to the switch if you're disconnecting the switch from the board? Like to the new switch? Yeah,
so there's you mean for the jack?
For the jack, excuse me, yeah.
So you have a tip, and then a grounding connection, and then your shorting lug. So you connect the
so you just run it off of the slots after you pull that jack out of there?
Yeah, exactly. You just run a new cord to the tip, a new cord to the ground. To the ground. Right to the switch. I have a I have a video on my YouTube channel that tells you, shows you exactly how to replace it, and I have a little diagram and everything. It's on my
Are you gonna pull this? Are you gonna pull this board for us?
Yeah.
Let's pull the board.
Yeah. All right. Let's pull the board. So they're the main things. You can look on the Excel spreadsheet. It's these caps and that jack, and then I kind of give this as an option. You can replace these capacitors here, but they tend to last longer. They don't have a lot of voltage going through them. They're active capacitors, and but that's what, if you look at my Excel spreadsheet, that's what all that means. So, oh, you know what I wanted to show you?
Go ahead.
All right, so I just turned the amp on. I will keep your eye on this tube. It's going to fail. Oh, maybe it would help if I turned on my. All right, so amp's on. Oh shit, you know what? Nothing's working out today. Disregard. It's already failed. So you can hear the amps making noise, and you can hear like a buzzing. It's not supposed to sound like that. It should be fairly quiet. And I can tell this tube's not even lighting up. So when I was playing it before, you actually could see it would red plate, which means this little gray area in here turns like red, and then like the gases inside turn blue, and it's really cool looking. I was gonna try to show you, but it didn't work out. Like anything else, like my coffee, like the other amp, it's just not working out today. So let me pop this board, and then yeah, I could probably show you real quick how to do this jack. It wouldn't take long at all. Move some stuff out of the way. So a lot of this work you can actually, maybe I'll just, so a lot of times I just leave the amp in the chassis, pull these boards, and since y'all are new guys, ouch, son of a bitch, it's hot. Since you guys are all new guys, you're probably new guys, it's good to label all your tubes. It can help you trace problems that you may or may not even be aware of. So I'll, in amps like this, 1, 2, 3, 4, 5, just like that. That's how they're labeled in the schematic too. So not every single amp is like that, but all Fenders are labeled like that. So pull all tubes, send them somewhere. Yeah, and they can be hot. Obviously, I just burned myself on one, but so be careful with that, especially EL84s. So I got my discharge stick that I made the other week. Make sure it's disconnected from your power, and then start taking the knobs off. Oh yeah, I forgot these don't have the pots aren't connected to the board, so it makes things actually a little bit easier. So in the spirit of teaching you guys the right way to do things, I'm going to check to make sure there's no voltage on these caps. So the side with the indent is the positive side, and that's where you would get voltage. So I'm looking at my multimeter off screen, and I got nothing. So good to go. Disconnect that guy. Get my drill. So all in.
What about Death Cap for Cutie for a name? Do you think that would be a good name?
Oh, hell yeah. Dude, I think didn't we talk about that? Why does that sound familiar?
Because I can't get that out of my head whenever I hear Death Cap. Because I'm a child.
That's great. I like it. Everything should be yeah. A lot of people, despise taking these PCB boards out, and like people won't even work on PCB board amps, not PCB board, PCB amps, but I don't work on all of them, that's for sure. Like I don't work on Mesas.
What are those companies that are making their amps hard to work on? What do they think? I mean, does that affect people down the line when somebody takes it in to be serviced and they can't find anybody to work on it? I mean, are they pretty much done with Mesa after that, or is that just not a concern in this?
Ask me again.
I'm just wondering, like, do the manufacturers worry at all about like guys taking in their apps and never being able to find anybody to work on them because of how they were engineered? Or
I mean, I imagine some people. I mean, yeah, there are some people that worry about that, but I don't think the big brands are.
I'll let you concentrate.
I'm just getting hung up. Yeah, I don't think the big brands are for sure. I don't think Fender built this amp for serviceability, even though they're not that hard they're really not that hard to service. You got to pull this board, and it is fragile. And there's something holding this board on, and I can't find it.
Reverb cable.
Say that again, Jonathan.
It's the reverb cable.
Reverb cable
at the back.
The cable is right here. It's not that. It's something in the middle of the board here. Oh.
Well, we don't want to put you on the hot seat, Luke. Nobody likes to get into a weird situation then.
It's okay. I work on dead people for a living, remember?
Yeah. I'll tell you one thing, there's not much more relaxing than watching somebody else work. So
if this was an amp that didn't have a PCB board, you needed to replace these components, you would just replace them, but you got to, that's why people don't like working on the PCBs. I think it's just getting hung up down here. So if you don't know what you're taking apart, you should label it, obviously. The Fender boards are pretty good at being labeled. So like this connector that I'm taking this off says blue. So I know this goes back on. Also, I know what this stuff does. So the more you do it, the more you figure that stuff out, the less you have to label, the easier the amps become to work on.
any chance they put some glue in there?
Son of And these these are called ribbon cables. They're very fragile.
Something to let go.
So you have to be careful with those ribbon cables.
What if you're somebody like me that doesn't enjoy being careful? Is this maybe not the job for you?
Yeah, probably. Bad for you.
Because I think I probably already would have launched a screwdriver across the room at this point.
Slow and steady wins the race. Some amps you gotta take you have to take like everything apart. And depending on what I'm doing or what I'm getting into, I will. Like this amp. See, I'm trying not to take all of these cables out. But sometimes you just have to.
Easy. Is that awful?
Yeah, say it.
Easy. I wonder, maybe we could do a new board game that's like Operation except on amps. And like do an amp repair like Operation except everybody's hooked up to electrodes that shock them if they hit the sides.
Just leave the amp plugged in.
Yeah.
It's just an idea. Yeah. You ever do that just for fun? Just see how steady your hands are?
Do not. I shocked myself pretty good. I left an amp on one time and I picked it up. And legitimately electrocuted myself. Like I had a burn mark on one finger and a burn mark on the other finger.
That a lot of people don't know this, but that Peter Gabriel song about shocking the monkey was actually about his amp tech.
I forget his name, and maybe one of you guys even know. There was a musician who died by getting shocked by an amp.
Yeah.
He was like in his basement, bare feet. There was like floor was wet.
Is the lead singer for the Yardbirds. Phil something.
Always one more, man.
So this is why this is $85 just to do this nonsense, right? This is I get it now. I was like $85, holy moly. Luke's printing money over there.
And then if I break something, like I gotta fix it. And if I break it, well, within reason, if it's something that was gonna break anyway, but if I mess up and break something, then that's on me. So I kind of charge for that. $80 is an hour's worth of labor, but I mean that took me however long. Then I got to put it back in, and then if something happens, I got to take it out again and put it back in. That all gets taken into consideration. So sometimes.
So if the worst was to happen and you were to snap that PCB board in half or break it, is that an item that you can talk to Fender about and get a new PCB board, or is that or would you just buy a new amp?
I don't know. I don't know if you can get a whole new board. There are some amps that you can get whole new boards. Like Marshall sells some whole new boards for certain amps that they designed incorrectly. So all right, so board's out. And you can get this bottom board for Fenders, for juniors, and for the hot rod variety. You can get this bottom board that's like that people have made up on their own because these boards are kind of shit. So this one, yes, but this main board, I don't think you can get that. You'd really have to be screwing up to break a whole board. All right, so let me take this switch out.
Jonathan Radford in the chat says, let's see the bias on that thing, which I have to admit I don't understand. So I'm repeating what he says.
Yeah, so the bias is hot on these. If you want me to, I can.
When you turned the amp on,
I can show
sorry,
you
when you turned the amp on before, I thought you were going to show us, but the valve wasn't working. So yeah, doesn't matter.
I have another one right here. I can show you the bias on that one. Let me take this bad boy out, and then I'll show you the bias on the other one. So I don't always use the solder sucker for PCB stuff, but on this jack, the lugs are big, so you can use this sucker upper. But I'll hit it with the sucker first, and then I'll go back with the solder wick and clean it up. The important part is you don't want to just start stressing that jack. You don't want to just start stressing that jack until it pulls out of the board, because you can break the traces. You break the traces, and you're just turns into a whole thing. You don't want to turn it into a whole thing. So this is solder wick, and
Dan Earlywine, are you there?
Yeah, I'm here.
How's it going? Are you getting all this?
Good.
Should I come down there and we'll just shock each other and see what happens?
This is very relaxing.
Huh?
I just got back from having a pedicure, so it goes right together.
Oh, that's good. That's good. You got something, a StuMac video coming up where your feet are involved?
Oh, yeah, I'm working on one every couple of weeks, like the old days.
You got some foot operated files in the works?
I just kind of do whatever they want.
Yeah.
You heard Susan. StuMac's reaching out to young people to try to get them hooked into it. So it's the same shit over and over again, working on how to adjust the truss rod.
Mm-hmm.
But to really talk about that, it takes an awful lot.
Still righty, straighty, lefty Bowie on those, right?
Yeah, lefty, righty, loosey. This one, if it's a two-way truss rod, that's a different story.
Luke, are you ready to talk again?
Yep.
Okay.
Righty, tighty.
So snipping off some wire. Then, all right, so let's see. How well can you all see this? So there's
I had those same vans in junior high, and I destroyed them within about a week.
That's good camera work, man.
It is.
There's 4 lugs here. These lugs are connected to the same pad. This is a pad. You see how there's different I don't know what the word is, striations in the board.
Yes.
So they're all traces, okay, and they're copper, little copper pieces that run to the next place. So this is one big trace. This is the ground. This is for the ground. So you can tell that this one's connected together and that one's connected together, and then this one and this one is connected. But we don't need all of those lugs on the next one, but they're on our new jack. All we need is the tip and the ground. So I'm gonna strip the wire. Got a red wire for the tip, and a black wire for the ground.
That's keeping within the traditional color scheme for hot and ground, correct?
Yeah, black or green, actually. Oops. Sorry about that. All right, so I forgot. I always take this green wire. Oops. I take this green wire off and I can make a new ground connection to the actual jack. It's probably splitting hairs, but it's a better ground connection. Take a little pride in your work and clean stuff up. I'm not using this lug anymore, but I just want to clean up that solder. And then I'm gonna just connect. See, I want to connect it to the furthest lug. So it's away from the chassis. So, yeah, so it's away from the chassis. So the when the jack goes in, it doesn't get stuck on anything. I'm just squeezing the wire a little bit to make it more the shape of the hole in the PCB. I use a little flux, so a little dab will do you.
So on repairing these, like what's your cutoff price wise before things become they should buy a new amp thing? Or do you have people that are willing to like get things fixed just because they're not into disposability, or it seems like a shame to throw something away for?
Yeah, it depends. Like, I never suggest to anybody that they should throw something away. That's like all on them. You know, it's same thing as a guitar. You know, someone brings in a cheap Yamaha. There's a point at which you don't want to do the work because you don't know if it's going to work, right? Like, you don't know if it's going to work at the end or how long it's going to work. There are some amps like that where you're like, listen, I don't want to fix this for any amount of money because I don't know if it's going to work at the end. And then there's everything in between. You can tell somebody, listen, I probably could get this working right, but it's going to cost $500 and there's no guarantee that it's going to be perfect. Then that's at that point, a lot of times people will opt out of getting things repaired. But for these Blues Juniors, like, yeah, this guy's going to spend almost $400 in repairs to get this thing like top notch.
There's something too, like if you go out and buy a new amp, you're just going to be at this point again a couple years later, right?
Yeah. There's no reason for you to not repair your Blues Junior and go out and buy another Blues Junior or Hot Rod like that. You should just fix them, unless the board is toast. Sometimes the board will get just toasted. In that case, that would be listen, I can fix all these things. I can replace all of these parts on here. I can clean up the board. I can rerun the traces. But if the board is conductive, and boards can be conductive after they're burned, because it turns into carbon, and carbon is conductive. So depending on how thick that carbon is, depends on how it can transfer voltages to one part of the board that they're not supposed to be in. So if that happens, then yeah, the board is toast. All right. So now I will take my jack. Shorting jack. Oh, this relates into what we were talking about last week, Ian. So I pulled out my stash of jacks. I only got 3 left. We got 2 left. I don't know what that jack.
Time to talk to accounts receivable.
So I'm just gonna run over here and pull up my CE distribution list and add it to the list. 1/4 inch shorting jack. And I'll order about, I don't know, I'll probably order 30 of them.
30.
I order more.
Oh no, I wouldn't know. It sounds like a lot.
Yeah, well, like 1 amp, you know, depending on what you're doing, you could use, you know, you could, if it's a 4-input Marshall, you know, you could use 4.
Uh-huh.
You know, it's an old Tweed Deluxe, you could use 4. 1 amp plus the, you know, then you get, you know, use a lot of them. And you just don't want to have to order them every week either. That's the other thing.
Yeah. Yeah.
Right, so red is the tip. That's kind of long.
Jonathan, what's your part stash like? Are you a partsaholic?
It's funny. I'm just ordering jack sockets right now. It's a good reminder.
Oh, he gave you a little heads up, huh?
Yeah.
Like, oh man, that's right. I'm out.
So how many are you gonna order?
I normally order like about 20 like guitar jacks at a time, and maybe 10 or 15 switching jacks. There's kind of actually recently there's been a bit of a shortage. I noticed my main distributor for jack sockets, the cheapest place I could find, they had a sort of a back order. But yeah, I don't go crazy with parts, but those two are the most common things. And capacitors. I keep a good stock of F&T axial capacitors.
What's your move there for putting that on? You know, I was taught when I was coming up that to tin the lugs too. Is that not necessary?
Whatever gets the job done. I don't tin the lugs. You should old stock of stuff. You should tin. You should at least clean it, because you just get dirt and residue and stuff on it. I don't go crazy, and I might get some flack for this, and that's okay. I don't go crazy about the mechanical connection. Like, I don't want to be holding it when the solder dries, but I don't like tie a knot around my jack.
Well,
right?
I mean, I don't get the mechanical thing either. I mean, what kind of stress is that jack going to be under?
Well, actually, the jack could, the jack in this amp could have a lot of stress on it, because
okay,
you know, you're plugging the guitar into it, right? And then what if you trip over your guitar cord while it's plugged in or something?
You were saying before that, like, the old school like Navy manual was like you tie a shoelace knot on it, basically.
Yeah. Yep.
You mess around with like third hands or anything like that, or?
Yeah, I do. I don't know why I'm having trouble with this right now. I'd like to have like one big. See, I normally pull a chassis. You hear my kids getting yelled at?
Whose kids are getting yelled at?
My kids. My wife's yelling.
Oh yeah? Sounds like they deserve it.
Dude, they always deserve it.
What was the infraction this time?
Not being careful, trying to kill each other, probably.
Oh yeah. Head injuries. Gotta avoid those.
All right. I think you guys are making me nervous, and this is turning into a mess. All right. So can you see what I'm doing there, kind of?
Yeah, we're good.
So I got. So it's the wire is just kind of sitting in the hole. It's curved around a little bit.
Uh,
And now I'm just going to solder. I mean, you guys know how to solder jacks.
yeah, but it's always interesting to see another person's technique. That's some fine solder and fine soldering.
I'm just going to clip the wire that's closest to the board. And then we'll change the way I'm holding it. I'm gonna run the ground wire up through the shorting lug and into the ground lug. That's why I made that.
I've never heard shorting lug before. Can you explain that to me?
Yep.
What that means?
Yeah, so there are, it's not, I might be using the wrong word. It's not really called shorting. It's just it's called a switch, because you can wire it up to do different things. But all right, you just solder this up and then I'll get a shorting. So what I'm doing right now is I'm connecting the ground to the switch lug, okay? And then my signal wire is connected to the tip. So when there's nothing plugged into the jack, the tip is connected to this piece of metal here, which is connected to this terminal.
Which effectively shorts it, right?
So it just shorts it out. If it wasn't shorted, then this would just kind of pick up some ambient signal. Sometimes it would be quiet, sometimes it wouldn't. It depends on what's going on in the atmosphere. But this makes sure that the signal is grounded right here until something's plugged in.
Cool.
That makes sense?
Yep.
Make sure all your joints are nice and shiny. If they're not shiny, this one was a little clouded. So I just heated it all back up. I got a little bit too much solder on there. Took some solder off. Nice and clean and shiny.
So the switch lug goes to ground, right?
That's right.
Okay, thanks.
It's on this particular amp, not on every single thing, but on this particular amp, it is. The way the inputs are ran on like two input amps is a little bit different. They're hooked up to like a resistor, and then the resistor's got to get hooked up to the resistor gets hooked up to another wire and goes somewhere else, and it's hard to explain without pointing out. So on a schematic, but that's just an extra, some insurance that the tip doesn't touch anything, because if that touches something, then it'll short out, right? So that's it. And then when I put it all back together, now I got to do all these caps and stuff too. But when I put it back together, I'll make sure there's a tooth washer on here, a tooth washer that looks like this, not one that looks like this. These, I don't know if these are anodized or paint. I don't think it's paint, but this is direct metal. This has something on it. So don't use these. These are fine for like guitars because you're not relying on that ground connection, but we're relying on a ground connection here. So I use this tooth washer.
Cool.
So I'm not going to go through the full, I won't bore you guys with going through the full way of disconnecting all this stuff, but basically what I do is I just snip all the leads. It's good if you don't know what you're doing to label it. And then And then sometimes you can just twist them off. There's glue on the board here, and I try to get that glue off as best you can. I don't go crazy about it. Little chisels are pretty good for getting that stuff off.
Micro chisel.
Micro chisel, baby. It's really not that big of a deal, even if you had to leave it on. If someone was standing here waiting to get their amp back for a gig, I'd probably just leave it in there. But you try to do a good professional job. Unless you don't want to be a professional and you just want to do half-ass work, then there's a market for that too. But it's not my market, so that's not how I do things. So I'll take all those off. Then these have to be unsoldered, so you can't just break these off. These have to be unsoldered. I'll just take a little solder wick, break the connection on the backside of the PCB, and then pull these through and add my new stuff. Nikon caps. Nikon caps are kind of the standard for audio grade stuff. So Nikon are good, Panasonic are good. IC brand is notorious for having bad capacitors. So that's why we're replacing all of these. Yeah.
Cool.
So let me show you, let me bring that other one up and I'll show you the bias real quick. That'll be fun.
That jack would be normally closed, right?
Mm-hmm. What do you mean?
The switch would be normally closed. And then when you plug in the 1/4-inch cable, then it's opening.
Yeah, yep, exactly. Here, let me show you.
Like active guitars, it'd be normally open and then it closes when you plug it in.
To give you the battery?
Yeah.
Yep.
Yep, you got it. So everybody see that clear enough?
Yep.
And then you plug it in. And
so is the one that would be, so is there one that does the opposite of that, where when you plug it in, it closes the circuit? Is that what you're saying, Nathan?
Yeah, they're both switching jacks, but the one that lots of guitar guys that have already for making the battery connection in the active guitar, that's not going to work in an amp. It'll do the opposite of what you want.
So it'll turn your amp off when you plug it in. Is that what it would do?
It'll be noisy with nothing plugged in, and then when you plug in, it'll mute it.
I kind of want to do that to somebody's amp and not tell them. That's a joke, by the way. I'd never do that to anybody's amp.
alrighty, so
Except for maybe Evans. It's too noisy over there.
I already did that to my amps. That's my jam.
all right, so we've got an amp. All right, so turn the amp on, let it warm up. Turn the volumes down, turn the volume down.
So Luke, what is bias in a circuit? I guess I don't understand what that means.
So John, feel free, if you're still there, feel free to step in if I say something that's could be explained better. But biasing is changing the amount of changing the current that runs through the tubes, to changing the current in the amp to match the tubes. So tubes have a resistance in them, and it changes how the current runs through the amp. And you need to adjust that up or down to get in that optimal range.
Okay.
you have a better way of explaining that, John?
No, I mean, basically, you know, each valve has a maximum dissipation, power dissipation. So like the RCA manual kind of has a load of specs for each different type of valve, and you're biasing it in a comfortable range. And I kind of explain it to customers like the easiest way they can think about it, which isn't really anything to do with amps, but like like your car, your engine idles at a comfortable rate. It's not over revving and it's not about to kind of cut out, you know. So I kind of explain it like that. It's just you can either have it working very hard or you can have it not working very much. But the sound is generally better in a sort of comfortable to.
If I was playing a guitar that or playing through an amp that needed to be biased, what would I hear? Just kind of like mushy noises, or?
Well, if it's over biased, if it's drawing too much current, it may sound really good, but the life of the valve of the tube, is going to be shortened. It's going to be running very hot, and it would probably overdrive earlier, like it would go into breakup earlier. If it's biased on the cold side, then it's the valve, the tube. I keep saying valve. That's what we say here in the UK. The tube would last for ages, but it would be quite a sterile sound. So there's kind of a point in the middle which most techs kind of set them at.
Is that something you discuss with the customer, like what they're kind of looking for from the service? To be honest,
I normally it's rare that a customer will ask for a specific bias unless the manufacturer has said, you know, we bias our tubes at this point, you know, 26 milliamps or 30 milliamps or whatever. Other than that, I tend to set them between 60 and 70, depending on the amp, sometimes 50. You know, if the client wants a kind of a longer life. But Marshall amps tend to be set around 70% of their maximum plate dissipation. Fenders I'll probably set anywhere between 50 and 60.
So what's the variability here? Is it in the Luke? Is it in the manufacturer of the tube, or is it in the power that's coming from the amp?
It's in the tube. So when you can actually request them give you certain current rated tubes. So if you see here, let me see if I can get this to show up. See how it says current 34?
Yes.
So that is what they matched it at on their machine. It's an arbitrary number that they made up. Like Groove Tube uses a 1 through 20 number, but this is medium match. So I think their system goes from like 1 to 100, with most things operating between like 20 and 70. And so if it was a higher current rated tube, it would be like, you know, it'd be 60 or 70. If it was lower, it'd be like around 20. I always ask for medium current rated tubes, which are already, usually they send me on between 29 and 34. That way, if somebody is on tour and they blow a tube, they can replace the fuse and just go get a set of medium current rated tubes and pop it in there, and they don't need to rebias it. That's a little trick. I probably should stop telling people that, because they're gonna eventually stop selling me medium current rated tubes. But that's the way Mesa does it. That's the way PV does it. If you read the manual, they say that if you order our tubes, you don't have to have your amp biased. And that's just because they all use medium current rated tubes for their amps.
It does seem like that's kind of, I mean, were there different ratings for tubes in the old days because there were different uses, or was it just like instability in the manufacturing?
It's well, I guess for lack of a better term, instability in the manufacturing. Tubes are the tolerance for tubes is very small. So they have pictures of like dumpsters and dumpsters and dumpsters full of tubes out the back of tube manufacturers. I think I forget what it is, so don't quote me on this, but it's something like for every 10 tubes that are made, only 2 actually go into being used. So there's a waste of like 80%. Because there's no way to figure out if that tube is working until after it's sealed up. So the components that they use is just very, very fragile.
Cool. So what is it when you plug your tube into a tube tester? What is it looking for?
So it's just it depends on what kind of tube tester. So there's tube testers that test they test transconductance, and they check amplification, and they check for noise. But those kinds of things are they're big, expensive systems that usually have to be created through like a computer program.
Oh, okay.
But the ones that we use, like I have just like an old one, they're just basically checking for shorts and checking for the gas. They do check this, I forget exactly what the thing is that they test for, but they test for how they test for like how the current's moving through the tube. So that's how you get like your low reading on the tube. But they're not really accurate. The old, like most of the old ones aren't accurate to tell you any real useful information other than like they're working. If you wanted to match tubes, if you wanted to see their amplification factor, transconductance, and all that stuff, you have to kind of create a system. So let's check the plate voltage. So first I'm checking the plate voltage. So the plate voltage is the high voltage that is in your amp plate voltage and your B plus. That's all your high voltage. So I have my meter connected to ground. I have my meter on DC volts, and this is one plate, 314 volts and 320. There's a difference. There shouldn't be a difference. I'm thinking one of the coupling capacitors for the phase inverter are bad. So I had it running through my current limiter. That's to just make, and if there was a short, my light bulb would light up instead of blowing the fuse. So that lowers the voltage. So I got 337, 346, difference of 10 volts. Shouldn't be a difference of maybe 1 or 2 volts, but not 10. All right, so you have to check to do the calculation, you need the plate voltage. So you check your plate voltage, and then I have a calculator. I'll show you the calculator. I'll screen share in just a minute. And I can show you how to figure that out. So
that amp's on right now, right?
Yeah, the amp's on. Yep. This is kind of a dangerous way to test the tubes, because
just gonna say you're not trying to lick the inside of that or anything, right?
No. Yeah, you have to be very careful when you're working on amps that are plugged in. So I have I'm switching my meter to measure the current. I got it switched to milliamps. And then I'm going to connect my red lead to the center tap of the secondaries of the output transformer. I know that's some big words, but there's 3 wires coming out of one side of your output transformer. There's the center tap, which is connected to your B plus. It's usually the red wire. And then there's then the other 2 wires are your plate wires, and they're connected to the plate of your power tube. It's usually a blue and a brown wire. To test the current, you touch the center tap, and then you touch one plate, and it shunts the tube through the meter. I got 21 milliamps. And it's very important to not touch anything, because you'll blow your meter up. Well, not blow it up, you'll blow a fuse in it. I'm exaggerating, but you do have to be careful. Then you check the other tube, 27 milliamps. So that's what we talk about an amp being balanced. So you want those two numbers to be close together. If they're not close together, it's typically due to the tube. There are things that create one being out and the other one then being not balanced. But if you're not sure if it's the tube or if it's the amp, you can just switch the tubes in their positions. So
if your tubes aren't balanced, what are you going to hear? Just
noise.
Like
you'll get
noise.
Yeah, because the way push-pull, so this is a push-pull amp. It has two power tubes, and the way that it works is one tube operates at 100%, and then it goes down to 0, and then the other tube goes at 100%, and they go back and forth. It's called push-pull, and they can cancel out noise, but if they're not balanced, they won't properly seesaw. One will go up real high and not very low, and the other one won't go up very high and it won't go very low. So the normal noises are canceled out due to the way that they're wired in the phase inverter. That's why it's called the phase inverter, is how the preamp signal gets into the power amp, and when it goes in there and it does this little flippy do thing, it cancels out noises. But if they're not balanced, they won't seesaw correctly and it won't cancel out those noises. So you'll get hum. So we got 21 milliamps. Our bias is 21 milliamps on one tube and 27 milliamps on the other tube. Now I'm gonna switch over to the screen share and show you my calculator, and you can do the math. But I'm a true millennial and I like calculators. So
can I just jump in and say one thing at this point real quick?
Yeah, of course.
So the way that Luke just showed the bias being tested just then, using that shunt method, it's really important. If you're doing like a voltage with your multimeter, you've got the ground clipped and you can touch the other end. When you're taking an amp current reading, once you've connected one end, the other cable is live. So just be really careful if you do this method that you don't hold the other probe in your hand, like don't touch the contact if one is connected. Does that make sense?
Yeah. So as soon as you touch it to that live lug, the what would be the black one has actually got current going to it.
Yeah, you've basically got the full voltage there.
Okay.
Yeah, so don't hold your red lead on the plate or on that center tap, and then be thinking and touch your face with the other lead.
Yeah,
you'll get that full 300 and whatever volts on your face. Yeah.
The worst 9-volt battery like you've ever had. Yeah. Is there a safer way to do that, or is that the only way?
Yeah, there's a bunch of different ways. You can get a tube tester. Which screen can you guys see? You want to switch it back to my phone, Ted? The one with the amp on it. You can get this. You can get a tube tester.
You're still screen sharing, Luke.
All right, that's okay. I can show you. Oh,
yeah,
there we go.
There we go.
Here you go. You can get a tube tester, right? And this plugs right into the amp. And I've worn this out. They don't make these anymore, but there's a bunch of different brands that make bias meters. The best ones are you can hook all four tubes.
So you just throw that in, and then it tells you what the voltage to your tubes is.
Yeah,
and you can also
so wait, hold on a second. So why is that different to the tube? So there's different like the variation can be in the voltage going to your tube sockets.
Why is 127 and why is 121?
Or why would it be different across different amps of the same make and same model? Or would it?
The tube is changing the bias.
Okay.
Does that make sense?
Oh, okay.
Remember we were talking about the variations in tube?
Okay.
Yeah, that's why
Okay.
there's a difference.
Okay.
You can also test the bias by placing a 1 ohm resistor in between the cathode and the ground. So on fixed bias amps, so amps that you can adjust the bias are called fixed bias amps, and you can attach a 1 ohm resistor between the cathode of the power tube and ground, and then you can measure the millivolts between the ground connection and the ground connection and the cathode, like just on either side of those that resistor. Some amps even have test points where you can do that, and you could also place a 1 ohm resistor on the in line with the plate, I think. But you would actually have to change the circuit to be able to test it that way.
Okay.
So that is a way to do it. Like if you're not comfortable doing it the way we're discussing, like in Fender amps, it's no big deal to pop in a 1 ohm resistor between the ground connection and the cathode. And if it's your amp and you wanted it to leave it like that forever, you can leave it like that forever. Just pop that 1 ohm resistor in there and leave it there. I think that's how these bias meters work. I think they just have a 1 ohm resistor between the cathodes. You can make your own bias tester too. I think like Tube Depot sells a kit, maybe even C Distribution sells a kit where you can make it, but it's real kind of delicate stuff. I've never got into it. I either use my bias meter or I do it the way that I showed you. But the way that I showed you is dangerous. So you do have to be just cautious when you're doing it that way. So we got our plate voltage and we got our current reading. Now I'm going to take it to the screen share and show you the bias calculator. All right, bias calculator. So it's on C Distribution site. If you go into their tech articles, it's in there. I think even if you just Google bias calculator, it shows up. So you input your plate voltage, which is that first measurement we took, and then you pick your tube type. You click EL34, you hit submit, and then it gives you all of your readings that you might need. So I usually bias around 60%, depending on the amp, but 60 to 70 is kind of the sweet spot. And again, it depends on what people are doing. If I bias in a twin reverb, I do typically ask like, what kind of music do you play? What are you going to do with this amp? And if people say, well, I keep it at like 2 or 3, I play really clean, I like a good chimey sound, I'll bias it higher, like up to like 70%. But if someone's going to be cranking it at 8, 8 or 9 all the time, then I'll typically bias it a little lower so the tubes aren't running as hot and it breaks up earlier. The colder the bias, the quicker it'll break up. The hotter the bias, the more headroom and chiminess you'll get. Amps sound better when they're biased hot, but they'll blow they'll blow the tubes up. So this is on fixed bias amps, class A, class B. That's a push pull. It's typically your 2 power tube amps. So your Marshall JMPs, your JCM 800s, the amps with like 2 or 4 power tubes. They're usually fixed bias. And then your smaller amps like your Champ, your Tweed era like Princeton's and Harvard's, they have 1 tube or 2 tubes. Some of the later ones do have 2 tubes, but they're biased through their cathode, like the preamp tubes are on most amps. The 12AX7s are cathode biased. So on the cathode, instead of it being directly connected to ground, it's connected to a resistor and or a capacitor. And that creates the bias. And those amps operate at like 100% of their bias point. So that's why these numbers are here, because that's the current rating. So that's another discussion when we're talking about when we're biasing amps. We're fixed bias amps, two power tubes, 2 or 4 power tubes. You're looking at 60 to 70%. If it's a high gain amp, like a modern Marshall, like a JCM 2000 or something with like a bunch of like preamp gain and switches and knobs that like, and people aren't really cranking up to 100. I usually bias those amps a lot cooler. I bias them around like 50%. I don't really go below 50 and I don't really go above 70. This Blues Junior, I'm going to bias at 60%. EL84s run hot all the time, like by design. They're like one of the most common like failure tubes. They just run super freaking hot. It's just how they're built. So I'll bias it around 60%. This one's already, someone changed the bias in this, and it's already down to 21, except for that one tube, which was 27, which brings the bias point up to 28. So these tubes are kind of out of the spec of being matched. You only want like a 10% difference. You only want a 10% difference in the bias current between tubes. So if it's above 10%, then you should look at trying to find a better set of matched tubes. Yeah, so I'm going to replace these tubes, and I'm going to replace those tubes. Actually, that'd be a good experiment, real quick, and then I think I'm just going to wrap it up. Anybody got any questions? I'm going to pop these tubes out. And
can you stop your screen share just
yep,
so we can watch you taking the tubes out?
Yep, I think Ted got it.
Is this something you should turn the amp off for, or is this?
I mean, I just turn the amp off because it'll cool down the tubes. But it's anytime you can turn an amp off, you should turn the amp off. But obviously, we don't do things that we're supposed to do. I'm just pulling the tubes out like this because I don't want to take off a piece of tape. EL84, I mean, most tubes are hot, but EL84s get super friggin' hot. And glass is hot, so if you jar them and then put them down, you could break them. So be careful.
Is there any rhyme or reason to the letters and stuff? Like, what does the E stand for? Electrical? Or
I don't know. Turn the amp back on. Yeah, I don't know. So like tubes can have, I'm sure they do stand for something. I'm sure they didn't just stick random numbers on them, but like a 12A, I know this isn't your question, but a 12AX7 is the same as an EC83. It's the same as a 7025. It's the same as a what the hell is the other one? 52 something, I don't remember. Like a 12A U7 is the same as an ECC82. It's the same as the 5963. It's the same as a 5814. It's the same as a 6189. I don't have it memorized. I'm reading my notes that I have on my walls. Oh, the 12AX7 is also the same as an ECC803 and an EA3CC and a 6681. A 7025 is the military equivalent of a 12AX7. So when the military got a hold of tubes, they labeled them differently, and they labeled them as 7025s. They're more robust tubes. Nowadays, all these different numbers really don't mean anything. So a 7020, if you go buy a 7025 preamp tube, that's a new preamp tube. It's just a 12AX. Like they're the tube the tube companies just don't have the ability to make tubes any differently than just making a 12AX7. I'm not explaining that well. And back in the day, there was all kinds of tube manufacturers. So some could make a better tube than a 12AX7. So they would label it a 7025 and they would sell it to the military. But now you can't, like 12AX7 is a 12AX7. You pay $12 for one, or you pay $50 for the 12AX7. If it's a new production, you're splitting hairs. most of what the cost difference is how they test them in the depths of what they test. So amp company might buy 1,000 tubes, put them through a bunch of tests. They fail 500 of those 1,000 tubes and they sell 500 tubes. So they're going to charge more for them because they put them through a bunch of different tests. I could go on all day. All right, so I got to switch. So I'm going to just double check my plate voltage again, switch my amp over to DC, ground connection, make sure my meter is switched, and then check plate. Got 330. Got 330. So the reason that the plate voltage might change a little bit is there's always some variation in your line voltage. So if someone starts washing some clothes, your voltage will go down in your house. 332, 318.
But you do need those clean clothes, right? So it's totally worth it.
I guess so. All right, so switch it back over the current. And you know what the other thing is I was thinking about this amp. All right, hold on. I may stop talking while I'm doing this. All right, milliamps, switch my meter over, red lead to the B plus. 23.
Steady hand.
I had 21, now I got 23 and 21. So that's within 10%, right? It's within 2 volts.
So am I getting this right? Biasing is just selecting the right tube from your pile of tubes?
Okay, no. So
okay.
Yeah, yes, it could be that, right? Like, all right, you can switch me back over to the computer. So you could do that. You could just change the tubes out and see if you had a bunch of tubes, you could just keep swapping the tubes out until you find ones that match up. But obviously that's expensive and you got to have a bunch of tubes on hand to find the right ones. There's a resistor in fixed biased amps that you can change to a potentiometer to change it to a pot. So in a lot of Fender amps, blackface Fenders, there's a pot in there and you can adjust the current up or down. It's just the pot's in there. It's just wired as a variable resistor and you can change it up or down and that will change the bias. Blues Juniors don't have that pot. There's just a resistor in there. So a good modification for these is to put a pot in there that you can change the bias on. And that's what I'm going to do with this one. I got a little PCB board mounted pot. You drill a hole in it for the third leg, and then you wire it up underneath of the board. And then you can adjust the bias anytime you change the tubes. The other way to do it is just to change the resistor. And on this amp, someone had already did that. They put a wire in there and then they wrapped it around there and they soldered it together and they changed the bias. Most of these amps are biased at like 80-90%, which is like super hot, and they burn up tubes and they burn up components on the board and it's not good. So everybody modifies these amps because of that. But I'm going to
last guy.
Yeah, well, he added a resistor, which is fine. He did bring it down. He did bring the bias down, but the tubes were worn out and they became unbalanced. So typically, well, I assume that they became unbalanced. When tubes start to wear out, they can drift in value and then they'll go out of balance, and then that's when they're failing. So actually, this bias is right at 22 milliamps with those new tubes in there. And if the guy was hard up and didn't want to put the money into doing all the things what
would you get to put a pot in there? What's that mod run a customer?
$20. But I got to pull the board and all that shit. So it would be $180 to just do a pot, right? So it's $80 for the service, $80 to pull the board, $60 to replace those electrolytics, $20 to replace $40 to replace all those other little capacitors in there, then $20 to do the input jack, and $20 to do the bias.
This is one of those things that's like you know, like as a consumer, when guys say, well, there's all this stuff that I got that we might as well do while I'm in there because, you know, we're already in for a penny, in for a pound. And I go, all right. You know, like, so this is that stuff. We're getting an inside look at how bills are formulated by electronics guys.
Yeah. Yeah. I mean, it really, usually people opt to do everything or nothing.
Yeah.
Typically when people like, everybody likes their Blues Juniors, everybody likes their Hot Rod Deluxes, so they don't mind sinking. They usually don't mind sinking money.
Yeah.
And there's a bunch of different mods for like Blues Juniors and Hot Rods. I almost always talk everyone out of doing any mods other than replacing the things that I talked about for like reliability's sake. And after we do those things, the amps run better and they're quieter and they're robust, and people don't really want to modify them any more than that.
Yeah.
I mean, if I do them, and this is how I convince people not to do them, it's because if I say change the mids pot out to get a different sweep and change the capacitor and to try to get like a different sound with the mids, then you don't like it. Well, now I got to open it back up and pull the board again and replace all this stuff and put it all back. So like, what if it gets worse? You know, so that's my one of my mentors said early on about mods. He told customers, he said, how much did mod my amp to do this? $80 to put it in and $80 to take it out. So, and then they're like, what do you mean take it out? Like, well, when you take it home and you don't like it, you want me to take it out, I got to charge you again to, you know, take it out. So yeah. It is true. It's always a conversation. I usually say it in a nicer way than that. But
well, now there's a whole, I'm sure there's no shortage of examples online where you can hear the difference between mods. Like in the old days, like it was like, I heard about this in Guitar Player magazine.
Yeah. Yeah.
With my little plastic record that I put on there.
Yeah. So
all right.
I guess that's it.
That was very nice, Luke. I definitely learned something today. I saw Doug Proper playing with his phone the whole time, so I don't think he learned anything. He's going to do poorly on the quiz as a result. But yeah, thanks, man.
Yeah, well, things can get a little complicated really quick, and thanks, John, for piping in and helping me out. And
yeah,
nice one. It does unravel really quick, so it's a really complex, deep subject. It's like, so it's
all right, everybody. Hey, Sage Griffin, what'd you think? Did you have fun? Sage is here on, he's auditing the class. Not sure if he's still there. But anyway, all right, everybody enjoy the rest of your Luke Long. And once again, thanks a lot, Luke. That was awesome.
Yeah.
Thank you.
Oh, thanks, Nathan, you didn't chime in. I see you working near oscilloscopes all the time.
I could chime in on one thing. I don't want to hold you guys up, but instead of shunting the transformer, you could measure the resistance from the center tap to the line going to the plate. And that'll give you your resistance, and then measure the voltage drop across it, and then use Ohm's law to find the current. And then you don't have to be sticking two hands inside an amp with high voltage like that. So you just clip your leads on, measure the resistance, switch the voltage, turn it on, get the voltage, divide the voltage by the resistance, you'll get the current.
Oh.
Yep, just a little bit of math. Everything involves your friend. You learn a little bit of math, and you. That's a good. I forgot about that method. That's a good way of biasing too.
All right, everybody. Doug, you want to play us out? You want to play the practical amp repair theme song?
You just muted me.
All right, guys. Have a good rest of the day.
All right. Thanks, Luke. Thanks, Ian. That was really informative.
See you guys. See you next month.
Thanks, Luke.
Bye.